Download this code from codegive.com, link in the description below. OK, let's dive deep into React Native file structure best practices. A well-organized project is crucial for maintainability, scalability, and collaboration, especially as your app grows in complexity. This tutorial will cover recommended structures, conventions, and reasoning behind them, with practical code examples. Core principles and goals. Before diving into specific structures, let's consider the overarching principles. Readability. Code should be easy to understand by you, in the future, and other developers. Clear naming conventions and logical grouping are key. Maintainability. Changes should be easy to make without introducing unintended side effects. Modularity, separation of concerns, and well-defined interfaces are essential. Scalability. The structure should accommodate future growth and new features without becoming a tangled mess. This often means planning for future features by creating scalable design patterns early on. Testability. Components and modules should be easily testable in isolation. Dependencies should be manageable and mockable. Collaboration. The structure should be consistent across the team, allowing developers to easily find and understand code written by others. Consistent file and folder naming, along with common conventions, help to ensure new developers can pick up and work with the code as quickly as possible. 2. Recommended file structure. The most common and well-regarded file structure for React Native projects follows a modular and feature-based approach. Here's a breakdown. Explanation of directories. Android / and iOS / These folders contain the native Android and iOS projects, respectively. You generally don't need to modify these directly unless you're adding native modules or making platform-specific configurations. *src/*. This is where the majority of your React Native code lives. It's the heart of your application. *assets/ holds static assets like images, fonts, icons, and other media. Organize further into subfolders as needed. Components / contains reusable UI components. Each component should typically reside in its own folder. Button / a sample component folder. Button.js, the component's logic and rendering. Button.styles.js, styles for the component, using stylesheet.create. Index.js, a simple export to make imports cleaner, example import button from /components/button, instead of import button from /components/button/button. This is known as a barrel export. *config / stores configuration files. For example, you might have an API.js file containing your API base URL and any other API-related settings. Constant / defines constant values used throughout the app, such as colors, font sizes, spacing, and any other values that should be consistent. Navigation / sets up your app's navigation using libraries like React Navigation. You might have separate navigators for authenticated and unauthenticated users. Screens / represents the individual screens or views of your application. Each screen should also reside in its own folder, similar to components. Home screen / a sample screen folder. The structure mirrors the component structure. Services / contains code for making API calls and fetching data. This helps keep your components clean and focused on presentation. Store / if you're using Redux, or another state management library like Zustand or MobX, this folder holds your actions, reducers, store configuration, and action types. *utils / contains utility functions that are used across the app, such as date formatting, string manipulation, or helper functions. *app.js * the root component of your application, responsible for rendering the initial view and setting up navigation. *configuration files *slintr.js, .prettyarc.js, babel.config.js, app.json, package.json, and readme.md are standard project configuration files. 3. Code examples and detailed explanations. Let's expand on the example structure with some code examples. 1. src/components/button/button.js***. 2. src/components/button/button.styles.js***. 3. src/components/button/index.js***. 4. src/constants/colors.js***. 5. src/screen/homescreen/homescreen.js***. 6. src/services/auth.js***. 7. src/config/api.js***. Key points from the examples ***. Component folder structure ***. Each component has its own folder with the component file, .js, a styles file, .styles.js, and an optional index.js for cleaner imports. **styles in separate files **styles are kept in separate .styles.js files to improve readability and separation of concerns. This also makes it easier to share styles across multiple components, if necessary. **constants **colors, font sizes, and other constant values are defined in src/constants to ensure consistency throughout the app. This avoids magic numbers and makes it easy to update these values in one place. **services **API calls are placed in the src/services directory to keep components clean and focused on presentation. This makes it easier to test and maintain your API interaction logic. **configuration configuration settings, such as API base URLs, are stored in src/config. *index.js Barrel exports the index.js files in component and screen folders, provide a cleaner way to import components and screens. 4. Additional tips and best practices. Naming conventions **Use Pascal case for component names, example home screen, custom button. Use camel case for variable and function names, example handle press, API base URL. Use lowercase for file names, example homescreen.js, button.styles.js. State management choose a state management solution that fits your app's complexity. Redux is a popular choice for larger applications, while Context API or Zustand might be sufficient for smaller projects. Navigation use a navigation library like React Navigation to handle screen transitions and navigation logic. Linting and formatting set up ESLint and Prettier to enforce code style consistency across your team. Configure your editor to automatically format code on save. Type checking consider using TypeScript or prop types for type checking. TypeScript can help prevent runtime errors and improve code maintainability. Testing write unit tests for your components, services, and utility functions. Use a testing framework like Jest and React Native Testing Library. Version control use Git for version control and collaborate with your team using a platform like GitHub or GitLab. Code splitting, Lazy loading for larger apps. Consider using code splitting to load components and screens on demand. This can improve initial load time and performance. Environment variables. Use environment variables to store sensitive information, such as API keys, and to configure your app for different environments: development, staging, production. Libraries like React Native Config can help with this. Documentation. Write clear and concise documentation for your components, modules, and API endpoints. Use tools like JSDoc to generate API documentation automatically. Example of using React Native Config for environment variables. 1. Install or 2. Create .env file in the root of your project. 3. Configure Babel in your babel.config.js. 4. Usage in your code 5. Update .gitinary add .env to your .gitinary file to prevent sensitive information from being committed to your repository. 6. Rebuild your app You may need to rebuild your app after installing React Native Config. 6. Alternatives and considerations. Feature-based versus type-based structure. The structure presented here is primarily feature-based, grouping code by functionality. An alternative is a type-based structure, grouping all components, then all screens, etc. Feature-based structures are generally preferred for larger projects because they improve modularity and make it easier to find related code. Atomic design. Consider using atomic design principles to structure your components. Atomic design breaks down UI elements into atoms, molecules, organisms, templates, and pages. This can improve reusability and maintainability. 7. Conclusion. Choosing the right file structure is an important decision for any React Native project. The structure outlined in this tutorial provides a solid foundation for building maintainable, scalable, and testable applications. Remember to adapt the structure to your specific project requirements and team preferences. By following best practices and using consistent naming conventions, you can create a code base that is easy to understand and collaborate on. Good luck.